Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring solving absolute value equations, some of which will have something called extraneous solutions. Now this is part 2 of a 2-part lesson. Before we get started, let's talk about what an extraneous solution is. So an extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. Extraneous solutions sometimes occur when there are variables on both sides of the equal sign. So let's solve a couple of examples and I'll show you how to check to see if a solution is extraneous or not. Now I'll be using the Desmos calculator. You can use any calculator you have, just so long as you know how to get to the absolute value function on your calculator. All right, let's start with example 1. Solve each of the following and check for extraneous solutions. So in problem A, we have the absolute value of 2x plus 12 is equal to 4x. Now, our absolute value expression is already isolated, so that means I can go straight to step 2, which is to take the expression out of the brackets and set it equal to 4x and set it equal to negative 4x. So this is a situation where it is possible to have an extraneous solution because I have 2x on one side of the equation and a 4x on the other side of the equation. Now I'm going to solve these two equations separately. So I want to get the variables on the same side. So let's subtract the 2x here and we'll get all the x's over on the right side. So 12 would equal 2x, and then divide both sides by 2. So 12 divided by 2 would be 6. All right, now let's solve the other side. Subtract 2x from both sides, and that would zero out and give me 12 equals negative 6x. Now we're going to divide both sides by negative 6, so 12 divided by negative 6 gives me negative 2 equals x. So we have two solutions, and we want to check to see is one of them extraneous, or both of them extraneous, or maybe they're both legitimate solutions. So to check, I usually check on my calculator, and I take my original expression, absolute value of 2x plus 12, and then I want to see, does that equal 4x when I plug in my first solution? So on Desmos, the absolute value button is right above the ABC on the bottom left corner there. So absolute value. And then instead of 2x plus 12, I'll put my solution, which is 2 times 6 plus 12. All right, now I get 24. Now on a new line, I'll put in the right side of the equation, which was 4x. So 4 times x, in this case, x was 6. So they both equal 24. So I'm going to put a check mark by this first solution. This solution checked out. All right, now I'm going to edit this equation, and I'm going to change the 6 to my other solution, which was negative 2. So put a negative 2 there and a negative 2 there. So this time, on the left side of the equation, I get 8. On the right side of the equation, I get negative 8. So this is what we call an extraneous solution, and we must reject it. So for problem A, our only valid solution is x equals 6. All right, let's try this again, but we have to be careful on problem B. We have absolute value of 2x minus 3 is equal to 4x minus 1. So the absolute value expression is already isolated. So I can take it out of the bars and say 2x minus 3 equals 4x minus 1. And then 2x minus 3 equals opposite of 4x minus 1. Now, those parentheses are very important. Do not skip that step. All right, now we're going to solve each equation. So I'll start with the one on the left. Let's see, multiple ways you could solve this. I'll start by adding 3. So this would give me 2x equals 4 x, negative 1 plus 3 is positive 2. Now I want to get all the x's on the left side, so I'll subtract the 4x. So 2x minus 4x is negative 2x equals 2. Divide. 2 divided by negative 2 gives me negative 1. And we'll check that solution in just a minute. All right, now let's solve the other side. 2x minus 3. Now be careful here because this is an understood negative 1, and I must distribute that to 4x and negative 1. So negative 1 times 4x, negative 4x. Negative 1 times negative 1, positive 1. All right, now let's solve it. I'll start by adding 3 to both sides. So 2x equals negative 4x plus 4, and then add 4x. So that's going to give me 6x equals 4. Divide both sides by 6, so 4 over 6, and that reduces to 2/3. All right, now I'll come over to my calculator and I'm going to check my solutions. So on the left side, we have absolute value of 2x minus 3. On the right side, we have 4x minus 1. So I'm going to take my first solution and substitute in negative 1 for the x's. So absolute value bar, 2 times negative 1 minus 3 absolute value bar. All right, on the other side, 4 times negative 1 minus 1. So 5 equals negative 5. Nope, not true. So I have to reject my first solution. It's extraneous. All right, now go back and edit this. I'm going to delete the negative 1 and do a parenthesis 2/3, side arrow, close parentheses. All right, then change this negative 1 to 2/3, side arrow, let's see, what am I doing here? I need a parenthesis right there. All right, okay, now they match. So x equals 2/3 is your only valid solution to this problem. All right, problem C. Negative 3 times the absolute value of x plus 1 over 2 plus 5 is equal to negative 7. Now, on this problem, we do not have any variables on the right side of the equation. So we only have a variable on the left side. So there's no risk to us having extraneous solutions here. So I'm just going to solve this like normal. I want to isolate the absolute value expression. So let's start by subtracting 5 from both sides. So negative 3 times absolute value of x plus 1 over 2 equals negative 12. Now divide both sides by negative 3. So that will give me absolute value of x plus 1 over 2 equals positive 4. All right, now that we have our expression isolated, I can take it out of the brackets. X plus 1 over 2 equals 4. X plus 1 over 2 equals negative 4. All right, now to get rid of the fraction, I'm going to have to multiply both sides by 2. So 2 cancels with 2, leaving me x plus 1. And on this side, 4 times 2 is 8. Subtract 1. 8 minus 1 gives me 7. All right, we'll do the same thing on this side. Multiply both sides by 2 to get rid of the fraction. And that leaves me x plus 1 equals negative 8. And subtract 1 from both sides. So negative 9. Now remember, we're not going to have an extraneous solution over here, so we're going to accept both solutions. All right, what I'd like you to do is pause the video and try problem D on your own. When you're ready to check your answers, press play. All right, welcome back. Let's see how you did. So I said 2x plus 5 equals 3x plus 4, and 2x plus 5 equals opposite of 3x plus 4. All right, I'm going to solve each of these individually and then check for extraneous solutions. So I'll subtract 5. Again, there's many ways you could have solved this. So you may have solved it a little bit differently than me. 4 minus 5 would be -1. Now I want to move 3x to the other side. So that gives me -1x equals -1. Divide both sides by -1 to get x equals +1. All right, on this side we have 2x plus 5. Distribute your negative to get -3x minus 4. And that's the biggest place I see people make mistakes on this problem, is they don't distribute the negative correctly. All right, subtract 5, subtract 5. So 2x equals -3x minus 9. Add 3x, add 3x. So 5x equals -9. And then divide by 5. Now, I definitely want to check these solutions because I had variables on both sides of the equal sign. So I'm going to press my absolute value symbol, and my expression is 2x plus 5. So this would be 2 times 1 plus 5. Okay, and that gives me 7. Now the other side is 3x plus 4, so 3 times 1 plus 4. 7 equals 7. So this solution checks out. Now I'm going to change that 1 to a -9/5. Side arrow. That gives me 1.4. And then change this one to -9/5. Side arrow. And that equals -1.4. So 1.4 does not equal -1.4. So this solution is said to be extraneous. And our only valid solution in this problem is x equals 1. All right, if you need to pause your video to correct any mistakes, do so at this time. If you got this problem correct, let's move on to our last example. Example 2. Over the course of 2 days last winter, the temperature in a city can be modeled by the function T of h equals 2 times the absolute value of h divided by 2 minus 12, where h is the time in hours. And in part A, they want you to evaluate the function for t of 20. So t of 20 means we're just going to take the 20 and plug it in for the hours. So 20 divided by 2 minus 12. Now, we can evaluate this on our calculator, or you can do it by hand. If I evaluate on my calculator, I'd put 2, absolute value symbol, then a divide bar, 20 over 2, and then side arrow, minus 12, and then close your absolute value. So that gives us 4. So t of 20 is equal to 4. All right. B, for what two values of h will the temperature be 10 degrees? So I want to plug in, let me write down my function. I have t of h equals 2 times the absolute value of h over 2 minus 12. I want to put the temperature for t of h, and then we'll solve. So let me set it up here. Now, remember, before you can take the expression inside the brackets out, you have to isolate the absolute value symbol. So we're going to have to divide both sides by 2. So this will give us 5 equals absolute value of h over 2 minus 12. Now we can split and solve. So I'm going to say h over 2 minus 12 is equal to 5. And h over 2 minus 12 is equal to -5. So on this side, add 12. H over 2 would equal 5 plus 12, or 17. And then to get rid of the 2, we'll multiply both sides by 2. So this 2 would cancel with this 2, leaving us h. 17 times 2 gives us 32. Or excuse me, 34. All right, on this side, add your 12. Add your 12. So h over 2 is equal to 7. Then multiply both sides by 2 to eliminate the fraction. 2 cancels with 2. And 7 times 2 is 14. So for 34 hours and 14 hours will give us a temperature of 10 degrees. And that concludes today's lesson, solving absolute value equations with extraneous solutions.